All right, so that's how we're going to decrease non-contact muscle injuries. Muscle pulls happen when the tendon is stiffer than the muscle is strong. So when we do things to increase muscle strength, lifting a heavy weight, that's great. And then when we do that lifting a heavy weight, that's also going to cause us to lift slowly. Or when we do specific things like very slow eccentric loads or isometric holds, that's actually going to get even more positive energy going through, or positive load going through the tendon. We're going to get the stretchiness of the muscle end of the tendon. We're going to break cross links in there, and that's going to help get that stretchy bit of the tendon at the muscle end here. There's another thing, and that's happening when we have healthy tissue. There's another thing entirely when we have a little bit of an injury in a tendon. And in this case, I put the injury right in the middle of this tendon here. And what I'm going to explain to you is a process called stress shielding. So what stress shielding is stress shielding is when you have strong parts of the tendon and weak parts of the tendon. The way that our tissues evolve is so that they are evolved such that all of the load is supposed to pass through the whole tissue. Okay? It's a fibrous tissue like this piece of paper. And when I pull on this piece of paper, the load just goes through the tissue, through the paper. Okay? If I now have an injury here, what you think is going to happen is that you think it's going to tear. But if I load it normally, it's loading normal. And the reason that it's not tearing is because of something called stress shielding. Instead of the load going through equally, going through all of this, because we know that this tear is a weak spot. And if this weak spot is here, why isn't this weak spot causing this whole tissue to tear? And the reason is that all of this whole thing is made up of fibers, just like the collagen fibers that make up your tendon. When we've got an injury, this weakness here will be filled in quickly by healing tissue, but then most of the load has to go around to allow the healing to occur. This is a process called stress shielding, where all of the strong molecules in the tendon take on the load so that the load doesn't have to go through the weak part of the tendon, and so that we don't get catastrophic injury. Okay? So when we load dynamically or quick loads, tissue is working perfectly. Because it's weaker than its maximum strength would normally be, but because it's shielding this torn area, we don't have to worry about us tearing the tendon completely. That's great for preventing catastrophic injury, but it's horrible when we try and fix the tissue, because in order to fix this tissue, what I would need to get load through the area, because the tendon cells need to feel the load so that they know which direction to make the collagen molecules. If they don't feel load, they're just going to send out collagen molecules in any kind of direction. And that's what we call a scar, non-directional collagen. So how do we get load through this damaged part of the tissue? In this case, what I'm going to show you is that something called stress relaxation. And stress relaxation is that if I hold isometrically, or if I hold the tension across this, over time, the strong parts of the fibers will begin to relax. And as they stretch and relax, load will go through the injured area. And in this case, because I haven't done any correction here, I haven't healed this in any way, I haven't formed a scar here, there's nothing to stop this thing from tearing. So if instead of loading dynamically, where it works perfectly fine, I load and I hold on it, if I hold long enough, without doing anything special, what's going to happen is that the tissue is going to relax and the tissue is going to tear. Because as the strong fibers begin to relax, the load is going to go through the torn area. And in this case, because I didn't have some sort of a scar material here that's going to help protect it, that's when you see the whole thing tear. Okay? So if we want to load to fix a tendon, this uses the same principles as what we were talking about before. We want a heavy, slow, or a heavy isometric contraction. Because if I just did that isometric contraction, I pull and I hold on that tendon, now load is eventually going to get through that area. And that's going to give the cells in that area the stimulus they need to know that they have to synthesize collagen in the direction of the load. And then what we're going to do is we're going to add a little bit of nutrition. Because when we give dietary collagen, either gelatin or hydrolyzed collagen to people, what you can see in this experiment is we gave people either a placebo, 5 grams or 15 grams of gelatin. We've done the same with hydrolyzed collagen. It works the same way. This is a measure of collagen synthesis. And what you can see is that the 5 and placebo groups are overlapping. So collagen synthesis is the same, whether you did a placebo or 5 grams of collagen. But when you give 15 to 20 grams of collagen, you can see that there's a statistically significant increase. There's a doubling of collagen synthesis in these people. So you can see that here, 15 grams of gelatin doubles collagen synthesis. And what we did is we gave them the collagen or the gelatin an hour before they did their exercise. So how would this work in principle? So this is a case study on a professional basketball player. So you can see this is his patellar tendon here. This white spot shouldn't be here. A tendon should look completely black like this. But this white spot tells us that he's got a patellar tendinopathy. And basically, he's had chronic pain for over 5 years. And this is a very difficult place to get load. And so what we did with him was he did a standard whole body training program. He played 50 games of professional basketball, and he integrated 3 times a week the stress relaxation training plan, where basically he used leg extension or leg press, where he'd do a 30-second isometric hold, and he'd hold that isometric for 30 seconds on the leg extension or the leg press. And then he would do that 3 times for each exercise with about 2 to 3 minutes in between as rest. 1 hour before he did his stress relaxation training, he would consume 15 grams of either hydrolyzed collagen or gelatin in 250 milliliters of orange juice. The orange juice is important because it supplies vitamin C. And vitamin C is required for our body to synthesize collagen. So basically eating the nutritional collagen is providing the amino acids that we need in order to make collagen. The vitamin C is providing the cofactor that we need in order for that collagen or the amino acids to be converted into collagen protein, and for that collagen protein to be laid into that tendon to fix the tendon. So what happened to our athlete? Well, you can see this is at the beginning. You see this big white hole here, and that hole is basically the patellar tendinopathy. This is a year later. You can see that the hole is almost gone, and you can see that by 18 months later that the hole is completely filled in. We've done the same thing with a bunch of other athletes throughout the world, and what you see is that this process can be as little as 7 weeks. So we see within 49 days that we can get a complete reversion of the tendon scar. All right. So this is how understanding the mechanics, the molecular biology, and some of the biology of what's going on, we can come up with ways that uses nutrition and loading in order to prevent injury in the case of the muscle pulls and to reverse injury in the case of these tendon injuries. So what I've shown you is that tendon is a shock absorber, and it's compliant on the muscle end, stiff on the bone end. When we do heavy movements, we make the muscle stronger, and the little shear near the muscle tendon junction causes crosslinks to break, and that decreases the muscle end of the tendon stiffness, and that's going to improve musculoskeletal health. I've shown you that fast movements are going to increase stiffness because the collagen molecules work like a sheet, and that decreases the shear, and by decreasing the shear, you're not breaking any collagen molecule, or you're not breaking any crosslinks. You're going to add new crosslinks, and that's going to give you a stiffer tendon. Okay? Once you've injured a tendon, what you find is that you can't get load through that injury until you use this kind of stress relaxation, where you pull and hold on the tendon. You let the strong parts of the tendon relax. That gets load into the weakest part of the tendon. That signal is now going to tell the cells which direction to make the collagen. By eating 15 grams of collagen or hydrolyzed collagen or gelatin beforehand with about 50 milligrams of vitamin C, that's going to give you the nutrients you need to synthesize the new collagen protein. And now you know the directionality, and those cells can now synthesize collagen in the proper direction and fix the tendon.